students, welcome to Veteach app. In the previous lecture, we have discussed regarding the water demands and how to forecast the population based on that. And further, to supply water to the public, we need to identify what are the sources and how to supply the collected water to the public through a transportation system, which is also known as conveyance. So in this chapter, we are discussing regarding sources of water and collection and conveyance of water. So this is the syllabus regarding that, and which I am going to cover in this session. And these are the contents. I have included part A and part B. Part A is regarding sources of water and part B is regarding collection and conveyance of water. So coming to the part A, sources of water, we all know that water is a basic necessity and it has to be supplied right from its source to the public distribution system. So to supply to the water distribution system, we need to know what are the sources and what is the quality behind it, quantity is available in it. We all need to know these factors, and based on that we'll adopt a system which be very economical and in terms of quality and quantity also it satisfies the needs of the public. In this slide we can see importance of water. One is the water distribution of earth, basic importance. What is the distribution on earth and its graphical distribution in different locations on the earth. If you can see overall percentage, the fresh water accounts for only 2.5%. In the 2.5%, we are utilizing whatever the demands we are requiring for the public, and from that 2.5, the different categories we can see which accounts in that 2.5. In the 2.5%, we can see glaciers accounts for 68.7% and groundwater accounts for 30%, 30.1%. And other remaining 1.2% accounts for only surface waters and other freshwater sources. By this we can assume that surface waters or freshwater water we are consuming or supplying to the public is of very less percentage, and from that less percentage we are distributing to the public, and from the distribution itself to even 1.5% we can see that ground ice and permafrost accounts for 69 and lakes accounts for 20.9%. Remaining 3% is from atmosphere or rivers or soil or from living things. We can categorize based on that. So this is the graphical distribution. Next is where we can see a different distribution from the different locations on the earth, which accounts more, and surface waters and groundwaters. So in general we can see the water distribution and water supply, what are the sources available and how much quantity we have to supply to the public. Coming to the Indian context, we can see that 2.45% of overall world's distribution we are drawing from the world's distribution percentage. That means from overall percentage available in the world's distribution water, we are drawing only 2.45% from that percentage. And from this distribution, more than 80% of the water supply accounts for is being drawn from the total percentage. So from this distribution, if we can categorize, only agriculture and industry withdraw an overwhelming majority of this percentage from this whatever percentage we are drawing from the world's distribution percentage. In this slide, we can see that water withdrawals by sector, what are the sectors available and what are the distribution percentage by different sectors across the world. If we can take total sectors and irrigation, industry, domestic, so different sectors drawing different distribution from the overall distribution. From that we can see domestic is accounting less than 1000 kilometers square per year. Overall year the domestic distribution is about only 1000 kilometers square, and the industrial sector, if you can see, it accounts for nearly 1000 square kilometers per year, and remaining irrigation is accounting for more than 2000 square kilometers per year. Overall to sectors and their distribution from this slide. So coming to this slide, basic definitions, we can see what are how the water is being distributed, or what is the cycle behind this distribution. We can see that hydrological cycle, precipitation, runoff, infiltration, evaporation and evapotranspiration. Runoff, infiltration, evaporation and evapotranspiration. If you can see hydrological cycle, the water which goes to the atmosphere and returns back to the Earth's surface, and in return it returns to the atmosphere. This continuous process is known as a cycle, and it happens continuously step by step. So the process happens like this, right from the precipitation till the evapotranspiration. It continues as a cycle. If you can see the terms one by one, precipitation The evaporated water from the Earth's surface goes to the atmosphere, it returns back to the Earth's surface. In return, this process is known as precipitation, happens by condensation. And runoff, after that precipitation happens, the form it is returned back to the Earth's surface. It is known as runoff. The runoff water will be through the surface or percolates to the ground surface. And next is that infiltration. Infiltration, some of the runoff water will try to percolate through the surface soil, known as permeability, and it is also known as infiltration. Evaporation, some portion of the precipitation is evaporated through lakes, through ponds, or whatever the sources available from ground surface sources. This process is known as evaporation. And evapotranspiration, whatever the evaporation is happening or whatever the runoff that goes into the groundwater, the trees, whatever the trees available on the surface of the earth, tries to receive the water through ground, and it tries to evaporate the water through the leaves. This process is known as transpiration, and as this process is happening through evaporation, this process is known as overall process is known as evapotranspiration. So in this slide we can see the hydrological cycle, how the process happens right from the evapotranspiration. In this slide, this is a video presentation we can see after that, and from the process starts from evaporation, it condenses in the air and it enters into the atmosphere. The process happens continuously, and there happens the precipitation. It returns back to the earth surface, to either lakes or ponds or river surface or whatever the surfaces available on the surface. So this continuous process is known as hydrological cycle, and this process happens continuously throughout the year. So we all knew that how the process happens, and we need to identify what are the sources and what is the quality behind that, and what quantity is available, so that we can have basic idea that what quantity is to be supplied to the public on what demands. Right from the sources, subsurface, it is categorized as surface sources and subsurface sources. Surface sources, what are the sources that are available on the earth, are known as surface sources. Examples like streams, rivers, ponds, lakes, oceans, all these are known as surface sources. And subsurface sources include what are the sources that are under the ground surface. Example, we can say groundwater sources. They are known as infiltration wells, springs, wells, infiltration galleries. We are going to discuss this. So the surface sources, the first thing is natural ponds and lakes. These are the sources that are available abundantly on the earth's surface, found by the excavations or general form naturally on the earth's surface through precipitation or runoff water. In this slide we can see the image source, natural sources in AP and Krishna district. So if you can discuss about the pond and lakes. Ponds are generally smaller than lakes. Lakes volume will be more than the pond capacity. Generally the quantity available in the lake will be more than the ponds, because the pond surface will be less, the catchment will be less, and the ponds lakes catchment will be more than the pond. So these are the natural water sources, and they are large water bodies. Their capacity also can be increased depending upon the demand by the public. From these sources we can expect a pure form of water, because they are still water and they do not move from the surface to surface. So pure form of water if it's undisturbed. But as it is a still water, we can imagine that water undergoes certain reactions with the atmosphere, and certain algae or weeds, generally these formations may happen. So the impurities, if we can see that algae and weeds and other vegetable growth can happen largely in these sources. Kind of sources is that copper sulfate treatment, which can remove these kind of impurities. These algal blooms are happening because of the reaction surface with the Earth's atmosphere and sunlight. So the reaction is happening, and the algal layers are formed on the ponds or lakes. So because of this algal weeds formation, whatever the problems we are facing is like odor problems or taste problems. And next is that streams and rivers, these are the natural source that we adopt for supplying to the public. These sources we are largely depending on for supplying to the public. So if we can take the primary source of any water supply project, these are the sources we primarily depend on to supply the water to the public. If you can take the consumption in the world, it is around 0.32%. Overall river percentage, it will be 0.16%. These sources are the self-cleansing velocity, because the water flows through gravity on its own. The impurities present in it will get removed with the flow of the water. So this can be self-cleansing velocity can happen in these sources, and largely because if it's disturbed or any human activity or industrial activity is happening from the surrounding of these sources, we can expect some pollution in that sources like human activities, industrial discharges, sewage effluents, rainfall runoff. Rainfall runoff can happen, pollute the water through its receiving of minerals or pollutants in the soil. The runoff water can collect, or as the water is a universal solvent, it can dissolve some impurities present in the soil, and through the runoff these impurities can enter into the receiving bodies like lakes or ponds, etc., and in streams as well. So the transportation cost involved in these sources is very less, as these sources transport the water by its own. There is no transportation cost involved. If we take the case of Andhra Pradesh, we have two major rivers, Godavari, Krishna, which we largely depend on. From these sources, three minor rivers are Pennar, Nagavalli and Vamsadhara, which contribute major surface water to the public. And the Central Water Commission has worked out the potential of surface water in Andhra Pradesh is around 78.9 kilometer cube. This is the volume of water that is available in Andhra Pradesh, with the catchment available for the public.